Hello, I'm TJ, and welcome to my garden. In this episode, I'm going to cover some issues with corn because it's a fun crop. I've grown quite a bit of it, especially over the last year, actually. And I'm tired of telling random people at various social events about it who probably don't care. So I'll tell you guys. Anyway, today we're going to talk about corn. In the last episode, I touched on a legal issue with one variety of corn that's coming up and kind of an innovative thing, which we'll talk about some more. But first, the very basics. I'm sure I hate to do this. I'm a big comic book geek, or at least I was when I was younger. I don't read as many of the superhero comics now as I did then, but I do keep up on a few things. But one thing I really don't like is how every time they do anything with Spider-Man, they have to start him off in high school when he gets his powers, right? You only get the first couple of years of Spider-Man again and again and again and again. Even though in the comics he went on to be an adult, get married. I think he had kids at one point. I don't remember if he and Mary Jane ever did have a kid in any of the comics. Probably at least one, I'm sure. Anyway, all these things happen in his life, but they only focus on that front. And I've noticed the same problem with gardening shows, that they all focus on beginning gardening. And unfortunately, I don't feel like I can talk about the complex stuff without the very basic stuff that you may have heard a dozen times if you know anything about corn. So if you know this, just fast forward a little. And I'll try to make this not boring for anybody, I hope. Anyway, corn starts with teosinte, which is a crop grown it's not really a crop grown widely anymore. It's a wild grass in Mexico. It was a crop at one point before it eventually transitioned into corn. Now, teosinte is harvested primarily for one reason, but actually for another reason, probably. I don't think we know this definitely, but it seems likely based on the way corn's used. So the main use for teosinte is sort of a food of emergency. It is a grain crop that you can harvest from the wild, and you can pop it or cook it up, and have it for its food. Actually, Native Americans early on don't appear to have used fresh corn that much. They mostly let it get to the dry stage and then popped it, and then they would actually make that into stews and gruels. So they didn't actually eat popcorn, and they didn't really eat fresh corn. They just sort of ate a gruel made with popcorn. And later on, they figure out nixtamalization, and they start making stuff with that. But early on, teosinte was something they used in emergencies. It wasn't very good food. It was hard and not very pleasant. And then later on, it became more stable in some of their other food sources. But kind of a controversial theory about agriculture is that a lot of it goes back to alcohol. Pretty much every major staple crop you can think of has a lot of starches and a lot of sugars, and pretty much every major staple crop you can think of in its wild form is not very appetizing. So, but they can all be used to make some form of alcohol, and many of them in certain situations can do this naturally. Obviously, honey being an obvious source of natural alcohol. Some other foods, if they're left to spoil, will naturally develop it as well, especially fruits. But with grains, it's a semi-natural origin in that after you've gathered them and set them out in a sack somewhere, if that sack gets wet and they start to sprout, they might start to ferment as they're turning those starches into sugars. They may then bacterially transfer those sugars into alcohol. And so the first sort of alcoholic beverages may have been unintentionally made porridges. They find their grain kind of soaked, smelling kind of cool. They take a bowl of it and give it a shot and have a little bit of fun that night and realize there's something to it. That seems like a likely path to domesticating most of the small grains, corn, a bunch of other crops that have similar properties. And sort of some evidence for this is the fact that one of the first written records we have is a grain bill for making beer. One of the first crops that we know humans actually grew were figs. Now, figs, obviously, you can eat the fruit, but another thing is figs are covered in the bacteria that causes fermentation. So it's full of yeasts that can be used to ferment alcoholic beverages. And we know they use them this way because we do find Paleolithic vases with little sticks in them, and on the sticks are little chunks or strings hanging down with little chunks of figs. So we know this is the way they made alcohol. So it seems likely this is the way they started using figs and started using these early grains. In corn, it seems a little less likely that they use the little rock-hard teosinte things, but one thing they do with corn is the stalks of corn contain quite a bit of sugar. Anybody who's grown corn has probably seen this when they've cut it down and they've noticed sort of the sopping wet insides of the corn, the pulp. If you cut it, you can actually chew that stuff up just like you would sugar cane. I've done it with groups of kids, actually. After we harvested all the corn and we cut down the stalks, I would cut the stalks into segments and we would cut off some of the outside and just chew the pulp in the middle, and they would realize it was really still very sweet. And this is after, keep in mind, this is after the corn has already extracted all those sugars to make the corn, right? Those sugars are there to feed the growing corn, but this is after it's put as much as it's going to put in there. This is just what's left, and it's still really sweet and actually kind of pleasant. I would recommend anybody, if you're growing corn, after you pulled the corn off, cut the stalks up and give it a try. It's really, really nice. And a thing is, they actually do make a form of, it's often called corn beer, but it's, I guess, technically more like a wine, or even closer to something like mead or the precursor to rum. They will press corn stalks and squeeze out all that sugary sap and then ferment it. And that's how they get several forms of alcohol in Central and South America and parts of Mexico. So we know they do this with corn. Seems likely they might have done that with teosinte. At least seems likely to me. They also make beer from corn cobs. They grind those up and ferment, and, well, they put in the water to get the starches out of the cobs, and they saccharify them, and then they actually make alcohol with that. They make beer from corn itself, from the actual grains. So it seems likely that because native peoples found so many ways to get alcohol from corn, that it may have originated that way. However it originated, though, somewhere along the line, there was a chance mutation in teosinte, and the cobs began to form more rows of corn. And that's kind of the genesis of where you get corn. Now, the earliest varieties of corn were probably field corn, which is similar to our modern flint corns. And from flint corn, you get dent corn when you get one mutation that causes some of the starches to convert to sugars, which causes those little dents at the end. They form a softer starch with more sugar in it as well, and that causes it to dent. If you get a mutation that retards starch development entirely and causes it just to produce a bunch more sugar, you get sweet corn. If you have a mutation that causes the hulls to get a little bit harder instead of developing more sugars, you get popcorn. If you have a mutation that causes husks to develop around each and every kernel of corn, you actually get husk corn, which, as near as I've been able to find out, was never a crop per se. It was grown for traditional and ceremonial purposes by some native peoples, especially Mexico. But it was basically kept as a curiosity and as an item for ritual purposes, for religious purposes. It wasn't ever really grown as a food crop, as I understand it, because it's very tedious. You have to husk each and every corn on the cob. So it's insane. They used to think that might be an early version of corn. Modern genetics shows that that's not the case, but there's that weirdness. So the main forms of corn all derive from this, and you get modern day flint corn. That's the really, really hard corn that they grow mostly as a field corn. That's used in making sometimes corn flours, massas, things like that. It's also used as animal feed sometimes, more often masa than that. If you get the starches, a little more of the soft starch, if you get the mutation that makes the starches a little softer, you get into the flour corn area. Those are even more made to make really far higher quality corn flours. If you get the mutation that causes a little bit of soft starch, you get the dent corn, which is used primarily as livestock feed. It's also used a lot in the biofuels industry now and things like that. You have popcorn, which has harder hulls, so they pop. And the thing is, you actually can pop flint corn. Popcorn pops way more reliably and gives you a better quality product. And then you have the mutation that causes sweet corn. Now, sweet corn gets really weird. I've got a little bit of a story. I should have time to tell it. I do have time to tell it. It's my podcast. I decide what I do. So, the sweet corn, you have the normal sweet corn, but then you have sweetness extender, SE corn, and sweetness, I want to say enhanced SH corn, or SH2, which is the super sweet gene. I'm sorry. SH2 is the super sweet gene. SE is sweetness extender, which causes it to develop more sugars and hang on to them longer. So sweet corn has a problem, right? Once you pick sweet corn, from the second you pick it, it starts losing sugars. Sweetness extender causes it to keep those sugars longer. It starts with more and it hangs on to them. So it makes for a sweet corn that lasts longer. And a lot of our commercial sweet corn varieties have that gene. Then you have the sweetness enhanced, the SH2. That just makes a really, really, really sweet corn. The texture of the corn isn't as good, but the flavor is really, really, really sweet. And both of these were found in bags of corn that had been exposed to nuclear radiation. And how did they expose them? Because they blew up an atom bomb. When they blew up the bombs that they tested at the Bikini Atoll, which is a sort of historical travesty because obviously people lived there and lived there for many generations, and the Bikini Islander is an ethnicity. This is their homeland. We moved them off the island and then dropped a nuclear bomb on it to test, so kind of a dark spot in history. But we had some boats moored off the coast with a bunch of seed because early on there was this big sort of experimental field of irradiating crop seeds and then growing them out to see if any cool mutations cropped up. We actually used to build farms with a big radioactive isotope kept inside of a pole that would slide up and down inside of a shaft, and so it would slide up, expose the plants for a certain period of time, and slide down. That's actually how we get some of our ruby red grapefruits. Some of those are the product of that. So anyway, these bags of grain, as they were experimenting with them, they found the sweetness expander and sweetness, the SH2 gene for the better sweetness. So super sweet and sweetness extended corns are actually from bombs set off on the Bikini Atoll. Those nuclear bombs caused those mutations as near as we can tell. They may have been present already. We don't know because we do find them naturally too. We find different natural mutations as well. But those two come from there. And we bred all kinds of varieties based on this, including varieties that have a mix of those genes in the individual corn kernels. So you'll have one cob that some of the kernels have one of those genes and some have the other. Another cool mutation is one which occurred in corn out of Asia. Now, this makes corn really, really glutinous. It increases the amount of corn gluten it has, and it makes it very kind of gummy when you're chewing on it. It's very chewy. It also can be used to thicken things, kind of like okra can or filet powder, right? You can put this in gumbo and thicken up your gumbo that way. And that type of corn, as just something you buy, is not common in the United States at all. But we've known about that gene for a while, and it's actually being used in corn breeding. It's produced many strains of corn that we use to this day that they, grow the corn, harvest it, and then break it down to extract the thickening agents, which they use in processed foods. There are tons of different varieties of corn. And then we crisscross them like crazy. So the other big fields of corn is you have what are called the land races. A land race of any crop is just a variety that's grown in a region, right? So you plant a bunch of plants, grow them out, collect seed, plant them again, plant them again, plant them again. Over time, they'll develop some traits unique to them. And there are many, many land races, especially of corn in the United States and in Mexico. Basically, that's the accurate description for every strain of corn because native peoples didn't really worry about breeding X type of corn. They'd breed a couple of different land races in their area for different climate conditions and things they dealt with. And so you have all these native land races, many of which fall into those broad categories of, dent, flint, popcorn, flour corn, etc. But a lot don't, because a lot were grown for one specific use. Like they had this specific dish they wanted, and so you have one that has a mix of traits from, say, flour corn and flint corn, right? It would be somewhere in between. And you have a lot of these in-betweens with Native American varieties. But then it goes even further in that we have at least one land race, which is one I was talking about before, and this one has some complicated issues surrounding it. So this is a land race developed in Oaxaca, right, which is in the very far south of Mexico, going closer to its borders with places like Guatemala. Now, in this region, they've developed a variety of corn over generations and generations that has aerial roots. So at each of those little nodes you see along the corn, it has those little stumpy roots that you usually see towards the bottom of other corn varieties, but it has them going all the way up. And these are covered in a gel. Now, they've studied the gel. They actually took samples of this many, many years ago. And, they've been debating theories and stuff about it since, but it took the limelight recently when somebody actually discovered that gel contains nitrogen-fixing bacteria. So this corn is fixing its own nitrogen, which is why in these regions in tropical Osaka, which if you remember from the last episode, I said tropical regions don't have the best soil, they're able to grow corn on land that normally would never be used for corn growing. It doesn't have any nutrients in it. It's just poor soils. But they're able to get pretty good yields from really bad soil, and it's because the corn is fixing its own nitrogen. They don't have to bring in the tons and tons of nitrogen fertilizer that we do in the U.S. They just let the corn produce its own. And we're trying to use those genes to get them into commercial varieties so they can do the same thing. Now, the problem here is that the research companies involved are having to having to deal with newer laws about how corporations and native peoples interact for biological resources those people have, like crops they've developed or traditional plants they use or their traditional medicines, things like that. Because obviously there's a long, dark history of people, especially European peoples, just showing up and taking that stuff. So they're trying to do those laws the best they can. The problem is those laws are kind of not all there yet. They're not very well organized. They're not very well, in some cases, thought out. So they feel that they're doing this appropriately because they're working with the village where they're getting these from. The problem is arising in that there are several other areas in the region that grow this very same variety of corn, and they're not getting any money from this. There are places in Guatemala that appear to be growing the same variety of corn. They're not getting any money from this. And there's a lot of debate over what kind of long-term profit sharing should be in place, because whatever patents the companies involved are going to get on this corn is going to cause them to get royalties for anything bred from them. And how much of that should go back to the native people who actually developed these varieties of corn. And that is a massive legal issue I am not really qualified to cover, but it is an issue that's going to color how this moves forward. So we are on potentially the cusp of another green revolution, which is a topic I want to cover in another podcast, because the green revolution itself is it's interesting, and it's a more specific thing than most people think of it as being. But this is one of those specific things that changes agriculture, right? Like the introduction of the potato into Europe changed Western history. We don't think of it as changing it, but the reason all those people were there was because you now had a crop that can support all those people. And all the political and cultural and everything history that came after is because of what that crop did. And we're on the cusp of something major like that too. We're on the cusp of corn that doesn't require tons of nitrogen fertilizer. And producing nitrogen fertilizer causes pollution when we do it chemically. It causes destruction of ecological diversity when we harvest, say, guano off of an island. When we're mining an island for fertilizers, we're destroying a part of that island to do it, and we're destroying habitat. So there are huge issues with the way we do farming now, specifically the way we acquire nitrogen fertilizer, and this could remove one of the most nitrogen-hungry crops from the list, which would just change everything. And so we're on the cusp of that. We don't know what's going to happen. And what they decide now is going to determine not only if that happens, how it happens, but also, is this going to be another case of history changing, but the people responsible for it kind of getting the shaft? So it's just something to watch. I'll post links to some of the articles on this. It's really fascinating stuff in the show notes. But yeah, corn is going to be a big deal pretty quick here. I mean, it's already a big deal. Most of your food contains some kind of corn, but it's going to be an even bigger deal. And I was really hoping to talk more about the diversity of hybrid corn and how that goes. That's going to have to be a corn part 2, because I am going past the roughly 15 minutes that I've allotted myself for these episodes. So it was great talking to you guys. We'll talk again. Have a good one. Bye.